How do we know the universe is expanding? Not because we guessed. Not because it feels like it should be. But because the universe itself left behind evidence, and once you see it, it's impossible to unsee. Imagine standing on a quiet road as a car approaches you. The sound of its engine rises in pitch, and as it passes and drives away, the sound drops lower. This happens because sound waves are being stretched as the car moves away from you. Light behaves in a very similar way. In the early 20th century, astronomers began studying the light coming from distant galaxies. They didn't just look at how bright it was. They broke that light into a spectrum, like a rainbow, revealing dark lines that act like fingerprints for elements inside stars. But something strange appeared. Those fingerprints were shifted toward the red end of the spectrum. This effect is called redshift, and it means only one thing: the source of that light is moving away from us. At first, scientists thought some galaxies might be moving away while others moved closer, like random motion in space. But the more they looked, the stranger it became. Nearly every galaxy was redshifted. Almost everything was moving away. Even more shocking, the farther away a galaxy was, the faster it was moving away. This wasn't random motion. It was a pattern. In the 1920s, astronomer Edwin Hubble made a discovery that changed our understanding of reality. The universe wasn't static. It wasn't frozen. It wasn't eternal and unchanging as people once believed. The universe was expanding. To understand this, imagine dots drawn on the surface of a balloon. As you inflate the balloon, all the dots move away from each other. No dot is at the center. From every dot's perspective, all the others are moving away. That's exactly what's happening in the universe. Galaxies are not flying through space away from a central point. Instead, space itself is stretching, carrying galaxies along with it. The farther a galaxy is, the more space exists between you and it, so the faster that space stretches. That's why distant galaxies appear to move away faster than closer ones. This relationship is so precise that scientists can measure the expansion rate of the universe, a value known as the Hubble constant. But redshift is not the only evidence. There is another clue, even older, left over from the birth of the universe itself. In the 1960s, scientists discovered a faint glow coming from every direction in space. No matter where they pointed their instruments, the signal was always there. This glow is called the cosmic microwave background. It is the cooled afterglow of the early universe, from a time when everything was hot, dense, and packed together. As the universe expanded, that radiation stretched and cooled, just like light from distant galaxies stretches into redshift. This glow is exactly what we expect to see if the universe has been expanding for billions of years. If the universe were not expanding, this background radiation would not exist in the form we observe today. There is more. When scientists observe very distant galaxies, they are looking far back in time. Those galaxies appear younger, smaller, and less evolved. This only makes sense if the universe was once more compact and has been growing larger over time. When you put all the evidence together, the redshift of galaxies, the relationship between distance and speed, the cosmic microwave background, and the evolution of galaxies, they all point to the same conclusion. The universe is expanding. But here is where it becomes even more unsettling. The expansion is not slowing down. It is speeding up. Something unknown is pushing space itself to expand faster and faster. Scientists call it dark energy, but that name is just a label, not an explanation. It makes up most of the universe, yet we cannot see it, touch it, or fully understand it. The fate of everything depends on it. If expansion continues forever, galaxies will drift so far apart that the night sky will eventually go dark. Stars will burn out. Energy will spread thin. The universe could end in silence and darkness, a state known as heat death. And yet, you don't feel any of this happening. Your body does not expand. The Earth does not expand. The solar system does not expand. Gravity holds small structures together. Expansion only dominates on the largest cosmic scales. So, while the universe grows unimaginably vast, your everyday world feels stable and solid, hiding the truth that everything is slowly moving apart. The universe is not exploding into space. Space itself is unfolding. And we know this not because we imagined it, but because the universe showed us. If this changed how you see the cosmos, like the video, share it with someone who loves deep questions, and subscribe for more cosmic wonders.